Good evening, everyone. I am K.S. Narayan. I welcome you all on behalf of the IIT Alumni Center, Bengaluru, for this 57th webinar. We have been conducting these webinars online since April 2020. It's been really a successful series, and in case you have missed it, you can find our previous webinars on our YouTube channel. We normally have this on Saturdays, twice a month, typically at 5 in the evening. I'm joined in here by Dr. Sushila Venkatraman of IITACB, who has been the key driver for these webinar series. Today's theme of the webinar, decentralized deployment approaches to energy sustainability, an extremely important topic, especially as we stand in this era where there is a delicate balance of energy that is required for economic growth and increasing our quality of life. And that needs to coexist with our planet undergoing serious climatic changes. So we have a distinguished lineup this evening to tell us more. And it's really particularly nice to introduce today's speaker, Anjan Ray, an alumni of IIT Delhi, whom I've known since his PhD days at University of Pennsylvania, where he did his PhD with the Nobel laureate Alan McDermott. And we were together as part of some good joint group meetings. After his PhD and his postdoc stint with John Reynolds, who's another accomplished polymer chemist, Anjan shifted to chemical industry and worked for nearly 2.5 decades across various functions involving quality control, technical service, R&D, marketing, general management, mergers and acquisition, corporate strategy. His professional interests have spanned fields as diverse as surfactant, oleochemicals, lubricants, coatings, adhesive, textile, cosmetic, pharmaceuticals, water treatment, energy efficiency, biofuels, and renewable energy. Anjan then came back to a semi-academic R&D environment as the director of a CSR lab, Indian Institute of Petroleum at Dehradun. He's also undertaken several responsibilities in CSR, including head research, project planning, and business development at the CSR headquarters. He was involved with CSR's concerted response to COVID-19 pandemic. And more recently, as the head of the Central Building Research Institute, he was involved with the monitoring, public confidence building, and impact risk mitigation of this demolition of Supertech, the Twin Tower in Noida. So apart from his professional career, Anjan has had an active interest in media, education, heritage, environmental conservation over his entire career. He's really truly a polymath. He's hosted live and recorded music and talk shows as an All India radio announcer. And I believe he's also a host of a podcast show involving classical Hindustani music. Now, today's webinar also involves our moderator, Tejal Kanitkar, who's an associate professor at NIAS, a National Institute of Advanced Studies in Bengaluru. She is a mechanical engineer by training and has worked on various aspects of energy planning and policy, climate change mitigation. Her research interest lies in the area of energy development and climate policy. She works on trying to integrate perspectives from natural sciences, engineering, and the social sciences to understand the interconnected aspects of energy production and the environmental constraint and economic development, with really a close perspective that prioritizes equity, and a very important fact, especially in this era of acute environmental crisis, such as this climate change. So we look forward to this lively webinar. I encourage the audience participants to engage in this discussion via the Q&A box, okay? Not the chat box. Okay, so with that, over to you, Anjan.
Thank you, KS. Thank you, Sushila. Um, and thank you to Tejal for consenting to be my partner in rhyme, if not in crime, for this session. The topic we're going to talk about is essentially this paradigm that economies of scale, a phrase most of us have heard, does it really apply to energy? Do we need to have big centralized power plants, big centralized refineries? How do I make energy sustainable and yet deliver energy equity at the bottom of the pyramid? While I'm going to broadly stick to this outline, I think it is more important that we have a dialogue. This is a subject where there is no single right view. It is a subject where you need to have a lot of data to make evidence-based decisions and evidence-based policies. You can't really do things based on just your beliefs or value systems or WhatsApp University, or even a few papers written by a few authors or scientists or scholars that you follow. It is a big, wide, complex subject. And how complex? I will try to give you a short glimpse in about 40 minutes. Further, that last part, the opportunities for India, is something I want to emphasize because India is unique. We know it, but we don't often act it. We have adopted technologies and concepts from the West over the last 60, 70 years without recognizing that it might not be the optimal decision for us. When the United Nations IPCC meetings take place and we negotiate the language of various agreements on climate change, we often find that the studies being cited are all studies from the West who have, as we know, been the leading contributors of carbon dioxide emissions over the past 260 years or so, without, in those 260 years, having had consideration for equity. And that climate equity underpins energy equity and underpins economic equity. In fact, for Sushila, KS, myself, 60% of the vertebrates that were there when we were young are no longer there. We also know, particularly this is being hosted out of Bangalore, and we know what the state of the freshwater lakes and the freshwater bodies in Bangalore and surrounding areas is today compared to 60 years ago. And very often the missing species, or the ones we don't notice, are the ones that are down there at the bottom of the pyramid. That's just the same as what happened with society. We don't notice insects that we have lost. We don't notice myriapods that we have lost. We don't notice that our microflora, our soil microbiome has changed in some way, because over the years, our soil has picked up much more nitrogen. We have over-ureated our soils. Our urban soils have picked up more heavy metals, especially as we start disposing of so much of e-waste. And countries like Latin American nations like Brazil, or those in the Amazon basin, where we've seen large-scale habitat destruction, see corresponding biodiversity losses. Now, the word sustainability, which is arguably an oft-used, sometimes overused, and occasionally abused word, let us just say that sustainability simply means that we should assure every species, not just our children, the same quality of life as we inherited from our forefathers. I have heard this phrase, we don't inherit the earth from our ancestors, we deliver it to our children. But actually, our children are children of all gods, not just of a lesser god. Our children are every species who will come by the time we are gone. And therefore, when we talk about sustainability, we need to have a common, global, and yet grassroots understanding of all its parameters. How did this term become popular? It's been around for a while, but when the new millennium came around, and if somebody asks me what I was doing at midnight on the new millennium, I was sitting in a war room trying to prevent a catastrophe from Y2K on my company's server systems. So I don't know where the rest of you were. But there was this belief that the new millennium should do something new. And maybe it has. We've seen some revolutions. We have also seen a lot of evolution. But what the United Nations and the heads of states and their emissaries to the UN had done was for the first 15 years of the new millennium, there were 8 Millennium Development Goals, and which guided development work across the world, particularly work that was funded by various UN agencies. And the objective was inclusive development. 15 years is very small on a historical time scale. It is minuscule on a geological time scale, and minuscule to minuscule, infinitesimal almost, on a planetary and universal time scale. But even in these 15 years, we learned something. At the end of 15 years, we learned that gender inequality was still very much around. There were still big income gaps, and that we can measure using this parameter called the Gini coefficient. It's simply a Lorentz curve, which is an integral curve of percentiles from 0 to 100 of people by income. So if everybody had the same income, you would have the line of equality at 45 degrees, and the Gini coefficient would have been 1. So with a Gini coefficient of Gini coefficient is 0, everybody has the same income. And at a Gini coefficient of 1, one person has all the income in a country and everybody else doesn't have anything. We can see, if I look at the countries with the highest Gini coefficients, and you notice carefully what these countries are, I will point out to you that almost all these countries were colonized. In fact, if I look at the countries with Gini coefficient above 30, almost every single colony, every single country there was colonized. And what colonization did, if I take the historical perspective, it caused a redistribution of resources between where the resources were mined or extracted and where the resources were used for economic value. This should give us an important message. It should give us an important message that if we do not allow effective and equitable distribution of resources, particularly where the resources exist, keeping in mind that not every place will have every resource, somewhere we will cause a skew. Also, to move resources even a few kilometers costs a carbon footprint, because every resource, in order to be moved, must be on some kind of a transportation vehicle. And a very simple maths will tell you, for example, if I take a diesel vehicle, and I'll just take a diesel truck for an example, the best diesel trucks deliver about, the very best will deliver maybe 6 kilometers to a liter of diesel. So every liter of diesel is about 0.8 kilos, and every kilo of diesel generates 3.15 kilos of carbon dioxide. So in 6 kilometers, a truck has generated roughly about 2.5 kilos of carbon dioxide. Now, this we multiply by the millions and millions of freight kilometers that we're moving on our trucks, our ships, our planes, or whatever else. And you can see that the farther I move a resource, the more potentially I am spending my very precious carbon currency or carbon budget. And I'm going to give that point back to Tejal when I invite her in a few minutes. However, it is not only climate change and social equity that we're talking about. What we also do when we have a skewed Gini coefficient, and when we don't have climate justice, and we don't have energy equity, is we reduce the opportunity at the bottom of the pyramid. A person who is not able to read at night because there's no lamp in his house, and we might hear a few stories of people who've gone and read under a lamppost, but for every 2 success stories that you'll hear of people who read under a street lamp, there'll be 2,000 success stories of people who gave up. Unfortunately or fortunately, the way we value jobs has also changed over time. So jobs that create wealth, not jobs that create income, tend to get paid more today. And therefore, poor people suffer the most because for poor people, wealth is a long way off. Sustenance, not sustainability, but just sustenance, requires income. It requires you to have a cash flow day on day, week on week, month on month, for which you need to have that income coming in. Take an example, take a farmer in a remote area, and let's take India. Less than 2 hours from Bangalore, if I drive out towards Hosur, and then I drive a little interior into Tamil Nadu, I will find actually places where the nearest petrol pump is 20 kilometers away from a farmer. That farmer, to drive his tractor, will drive 20 kilometers up and 20 kilometers down, and therefore will use at least 4 liters of diesel in getting diesel for his tractor. And in getting those 4 liters, he will emit about 10 kgs of CO2. Also, his opportunity cost, because a farmer essentially lives on a daily basis. He has to invest daily in his income. He has just spent an hour or maybe more than an hour going and getting the fuel, which for somebody who lives in the city and who has a white-collar job will be a matter of 10 minutes. It will be on his journey somewhere from a workplace to home or somewhere near his house or near her shopping market. And for a poor person, this will not be true only for fuel. It will be true for water. It will be true for a bank. It will be true for everything else. So why have we ended up urbanizing and centralizing so much of our activity? Is it because we saw the Western models of cities, and those cities became our aspirations? When I was small, at the time that all those vertebrate animals that we talked about were around 60 years ago or something, we only talked about 6 large cities in India. Today, there are many, many more with a population of over 1 million and several with population over 5 million. And urbanization without inclusive development has also caused urban poverty, which is actually worse in many ways than rural poverty because the quality of life actually goes down. And the more inequity we create, the greater the probability that we will have conflict, because conflict is, after all, the need to obtain resources from somebody who has them. And the greater inequity I do, the more the chance that we push people towards a resource-based conflict. Our Gini coefficient is 35.2 as of now. It has actually gone up, meaning got worse slightly during COVID, but not too much. And while we can say that we're much better off than many countries, we should not be competing with anybody but the best that we can be. I don't really like lists. Lists tend to compare you and tell you that so-and-so is doing better than you or so-and-so is doing worse than you. And that can either give you a false sense of ambition or a false sense of security. But if you look at where we are and what we can be, that is the gap that we need to examine. Anyway, the Millennium Development Goals got us to the 2015 point, and then came along the Sustainable Development Goals, using the 5 Ps, using the well-being of all people. Notice we didn't say all species, so even the SDGs are still very human-centric. But it acknowledged the interdependence of different things. It tacitly acknowledged that GDP was perhaps not the best metric of progress, and it sought integrated thinking and integrated deployment. These are the 17 goals in the SDGs, and I've highlighted 7 and 13 for our talks today, for the talk today. But 7 and 13 are interdependent on all the others, especially on things like number 17, partnerships for the goals. Because in any value chain, if every participant in the value chain does not receive an equitable share of the value in the value chain, sooner or later the value chain will collapse. Let's remember a couple of very basic rules. And I encourage a lot of you who have not read Ismail Serageldin to read his writings. 2 very simple rules that are very powerful, the input and the output rule, tell us that with non-renewable resources, we must keep developing resource substitutes and reducing the rate of depletion or extraction. But even with renewable resources, we must harvest them at a rate less than the regenerative capacity of systems that produce them. So even when we talk solar or wind or biofuel, so if I'm going to plant trees for biofuels and I cut them down faster than I can grow them, my net carbon stock is going to be disadvantageous to the planet. Similarly, the output rule tells you that any waste, whether it's incidental or whether it's purposeful, is going to show up somewhere in the environment. And there is a biological absorption capacity that we must keep in mind. Nature is a great absorber. But when nature absorbs excess waste, whether it's air pollution or whether it's soil pollution, we become or we place ourselves at risk of unpredictable behavior because we don't have the ability to model every single thing that nature will do to respond when we have overburdened her or some component of her. So whether it's flash floods or droughts or pests or anything else, which we read of even in our mythologies or in our scriptures, it would seem that whenever we have caused imbalance, that imbalance has come back to haunt us. The easiest way to see that is this rather interesting graphic. And we can see that while GDP has gone up and population has, as we know very well, has gone up, and foreign investment has gone up, everything else has also gone up. So what have we gained? Is it a zero-sum game that good things and bad things go together? Or is it that we have not yet learned to decouple growth from sustainability, or rather growth from environmental impact? The most common example we hear is carbon dioxide. The cusp, this portion where you can see that the slope began to rise and the rate began to increase, comes after the Second World War roughly. But it actually, if I had taken this line much further back, you will start seeing it after 1764, if we had the data, because that's when the Industrial Revolution took place. And after that, industry started. I will come back to this point because we would have all known as scientists, and as IIT alumni, as engineers, we all know that a machine takes energy and creates useful work. And it never has 100% efficiency. We can never convert 100% energy to 100% work. Therefore, by definition, every machine is using, or rather gainfully using, less energy than we put in, and that wasted energy is our contributor to carbon and climate change. Remember this, anything mechanical that is not at 100% efficiency, which means everything mechanical, is contributing to climate change. Now, we have to re-examine our premises a little bit better. And that's why when we say that it is better to cycle than to take a car, and it's better to carpool or take a train, you can start seeing how real that is at the ground level. This word that we see now, decarbonization, it's a subset of sustainability. It's one of the 17 SDGs, only one of them is climate justice. But it is the key to sustainability, because if we do not decarbonize and CO2 levels keep climbing, we are creating unpredictable effects on the earth. Those unpredictable effects may reduce agricultural production, they may increase extreme weather events, and in all of these, the people who suffer most are at the bottom of the pyramid. So very briefly, some decarbonization definitions that we hear. We will see these terms loosely bandied around in different articles and different YouTube videos and wherever else. But just to be clear, and just to make sure that nobody greenwashes you subconsciously, let's understand that if a company releases carbon dioxide into the atmosphere through their activities and then buys carbon credits or does an offset somewhere by planting trees, that is carbon neutral. It's not ideal, but it's better than nothing. Carbon negative actually creates an ecological benefit. It removes some CO2 from the atmosphere instead of adding to it or simply leveling it. Climate neutral is not only about CO2, but it also reduces all other GHG and eliminates all other negative environmental impact that any organization or any operation might cause. But the term that is now most popular is net zero. Net zero is an activity-based carbon emission lens, meaning that a particular activity releases zero carbon emissions into the atmosphere. Offsetting is not strictly part of net zero, it's part of carbon neutral. When we talk about greenhouse gases, there are really 6 that were listed in the Kyoto Protocol, which are the most potent. And most of our discussion will be around the first 2 today, carbon dioxide and methane. You can see that of those, of the carbon dioxide emissions, the bulk of it comes from fossil fuel and industry processes, not from forestry, land use, animal husbandry, etc. And methane comes from a number of other sources as well. But let's remember that it's not good enough to just do one and not do the other. The Earth is in crisis, and we'll have to do everything we can with every gas we can to bring it to carbon neutral, eventually to net zero, and finally to carbon negative. Whether it's transformers which use sulfur hexafluoride, so if a transformer bursts, you release this into the atmosphere with 3,000 times the impact, potentially 22,000 times the impact potential of carbon dioxide, and then it persists for 3,000 years. Or if we use F gases, which come from a number of sources, including, for example, Teflon, or these which are in the old-fashioned compressors or the air conditioners that you used to use, and still so in many countries. So all of these are things we must keep in mind. But for simplicity, in carbon accounting, we just say CO2 equivalent. So if you emit methane, you multiply it by 25 and call it a CO2 equivalent. That said, let us look at how this turns into international geopolitics on climate change. And here, let me invite Tejal, who is an expert in the field, has been one of the most vocal negotiators for India in the recent IPCC 56 Working Group 3. Let me bring her into the conversation.
Thank you, Anjan. And we were, in fact, negotiating together this particular working group. And so, very briefly, the IPCC has 3 working groups. The third working group that this particular slide shows is basically about mitigation. First one is on the physical science basis. The second one deals with impacts and adaptation. And there is the third group deals with mitigation. And the key problem, I think, that Anjan has also discussed so far is climate. Unlike issues of pollution that we have dealt with in the past, which are locally produced and locally managed, climate is an issue that is really a global collective action problem. If we do something unilaterally, if India does something unilaterally, it doesn't guarantee that we will not face the impacts of climate change unless others also take equivalent action. Right? And so therefore, it becomes a tricky situation. A multilateral negotiations, intergovernmental dialogue is a necessity here. While we can clean up local pollution, our rivers or our soil or our local atmospheric, particulate matter, etc., and we can definitely get benefits almost immediately. It doesn't work the same way with CO2, which is the main driver, as Anjan just showed, of climate change, which is really not a pollutant in the local sense. It's never been, but it is a problem when there's a higher than acceptable concentration at the global level. And so therefore, negotiating what needs to be done, who needs to do what, becomes critical, because it is a challenge. All processes, like Anjan said, and all modern processes especially, lead to the emissions of CO2, especially if we are using extremely concentrated forms of energy. And even 1 ton of CO2, in fact, leads to warming. It is, unlike some of the other greenhouse gases, it is a long-lived gas. It stays in the atmosphere for a long time, and so therefore causes warming. Despite multiple sort of shutdowns and lockdowns during the pandemic, we in fact saw an increase in temperature, because while local pollutants went down, aerosol pollution went down, which in fact masks some of the warming because it provides a cooling effect. You actually you had a net positive CO2 emissions, even though they might have been less than in those 2 years of the pandemic. They were not negative or they were not zero. And so therefore we still saw continuing. And this is what we are to discuss. Now, so the issue is really, and I think this is what Anjan is going to talk about, is what happens in the future in terms of mitigation. What do we do? Do we stop coal? Do we phase out coal? What does India do once it phases out coal? Do we phase out oil? Do we phase out gas? And does what India, if India does this, what impacts it has on us versus what does it mean, for example, for the US to move away from gas? Just as we are dependent on coal because we don't have natural gas, Europe and US are significantly dependent on gas. Whatever shift they've had away from coal has in fact been towards gas. And we have therefore a range of scenarios that talk about what is going to happen in the future. But these scenarios, as they are constructed, and again, Anjan has pointed this out, who constructs these scenarios? And so therefore, which issues are issues of equity, justice, poverty alleviation, the fact of the fact of energy poverty that we deal with in Southern Asia and Sub-Saharan Africa and Latin America? Are these questions central to the way in which scenarios are constructed? And if they are not, and I must submit in the IPCC, they are really not. So what is it that we must do to construct our own scenarios? Not because, there is some subjective basis, we are talking about, it's not as if you model what solar energy is going to do 10 years from now. The physics of it is going to be any different if you do it in India versus doing it in the US. But whether or not the US should move faster as compared to India is modeled differently depending on who does the model. And so therefore, the science of this climate change, the science of sustainability is not removed from its politics, is not removed from its economics. I think I'll just stop here because otherwise I can go on. But the importance of what Anjan, I think, is going to now go into about the economic models and the business models of doing this, and what it means for a country such as ours, which is resource constrained, it's poor, we have a lot of developmental challenges. And so therefore, what is it that best fits our interests is something that we really need to start thinking about without necessarily being led by models that are not basically done by us and do not address our questions. So I'll stop here. And there are a few questions, Anjan, 3 questions. And so one of them basically talks about, the fact that COVID has played a catalytic role for India to work on sustainability, whether it's basically because of shutdowns, et cetera, et cetera. There's been a lot of literature talking about what that means, whether people have been able to survive without, mobility and things like that, or motorized mobility. But are we? So the question goes that since MNCs and Western professionals were well ahead to work on sustainability, aren't we self-sufficient to predict and act on this rather than blindly following developed Western countries or reacting on pandemics to act on sustainability? That's one question. And then there is another question about, if there are any live examples, even if in a controlled environment, that at a societal level, negative CO2 has been demonstrated with confidence of sustainable actions. So, are negative emissions possible? Is it demonstrable? At what scale is it demonstrable? I think some of this it is given the focus on net zero and net negative. It's a critical question. So perhaps you can address that also. Thanks.
Thank you, Tijal. So let me take the first question, which is more subjective. Are we self-sufficient to predict and act on this in terms of sustainability? The answer is yes and no. We might be self-sufficient in terms of some capabilities, but if you remember Partnership for the Goals, unless we work in a global dialogue to predict the impact on us of something happening elsewhere in the world cannot be guaranteed unless we have data sharing from everywhere in the world. So to that extent, predictability is also a function of transparency. Our ability to act on this is also a function of our response time to crises. So if we look at typical crises that can arise out of climate, it could be a flash flood, it could be a drought, it could be a rise in sea levels, it could be erratic monsoons, it could be a locust attack. So I don't think we have a very straight answer, but I think a lot more work needs to be done collaboratively so that we move beyond thinking around just the pandemic as a catalyst and look at the global imperative of planet Earth. Talking about negative CO2 examples, we have a particularly clear case of a project that was started by steel mills in China and in Ghent in Belgium, where they take the off gas from the blast furnace and they're able to feed it to certain microbes, which then convert that off gas, which is carbon monoxide, carbon dioxide, hydrogen mixture. They convert that to ethanol, and then the ethanol is used to substitute gasoline. These are now almost at commercial scale. It's being done by a New Zealand-based startup, which is now no longer a startup. It's gone IPO'd, called LanzaTech. Some people refer to it as the hottest bioenergy company in the world. I would recommend you look at it. But for one LanzaTech, there are a million new ideas that it has spurred because it shows that a carbon negative approach is possible. I will try to show you some carbon reduction approaches certainly during this talk and things that are happening on the ground in India. There is one other question which I saw, which is other analyses which tell us which geographical regions will have the earliest impact due to climate change. And I think the answer is very much so. We know which are the vulnerable regions to climate change. They will be the regions that are closest to rivers that are glacier fed. They will be the coastal areas. They will be the areas which are already facing drought or low groundwater or groundwater contamination. Climate change is not a single impact. It's a very diverse set of impacts that affect regions. So any region that is already resource scarce in some resource or at climate risk, whether it's earthquake or something else, will be more at risk as climate change intensifies. That's a very general answer, but of course we can get into the details later. Maybe we should move on. Shall we get the slides back on? That's okay.
Yeah.
Thanks. So this is where we were, and this is what Tejal said, particularly the third point, that national circumstances are important. But the second point, that all fossil fuel consumption needs to be reduced, and some countries may reduce one, but they might have to reduce another one differently. So if I reduce coal to a lesser extent, I will have to reduce natural gas or petroleum to a larger extent. And when we hear phrases like we should replace IC engines with electric vehicles, we should be very careful that we do not actually end up with higher emitting electric vehicles somewhere else in the power grid because our grid is very coal dependent. Similarly, when we talk about green hydrogen, we should not forget that a lot of the industrial processes in the world use oxygen generated from fossil fuels or using fossil energy. But when I make green hydrogen, for every kilo of green hydrogen, I will produce 8 kilos of green oxygen, which will go back into the atmosphere without being used for processes where we could use it. So there's a lot more work to be done before we go and subscribe to any hype or to any statement. It is acceptable to consider a statement an aspiration and a statement of promise, but we should always look for evidence-based support when a statement makes a forward-looking projection of the quality of human life or of the planet. So this is one of the IPCC 56WG3 outcomes, that different combinations are consistent with a given warming level, which basically means that each country should figure out what will be the best that it can do to meet its targets. It doesn't have to be a prescriptive formula given by one study or one set of rules. But these are some examples. Use of low carbon sources, demand side measures, and reducing non-CO2 emissions. If I simplify all of that and come back to what I mentioned earlier in terms of input and output rules, what it really means is I have to focus on reducing the negative impact of resource use compared to meeting my developmental needs. And there's only two ways to do that. One is increase our desired economic output with less resource usage, or generate more output with the same resource usage. That's easy to say, not necessarily easy to do. But to understand how to do it, let's at least first start, because all of us are in some organization or the other, even if the organization is just a family unit post-retirement. And there are three scopes of emissions we should keep in mind. And while the first scope is the most visible, very often the third scope is adding a small incremental value, but a very large volume of impact across the world. Scope one is what you do directly. So if I am, to run my industry, I'm firing a boiler, I'm burning fuel, I'm generating CO2. Yeah? If I'm doing animal husbandry and my cow dung is out there and emitting methane, and my cows are being corralled and they're not free ranged, and they're ruminating for much longer periods, emitting more methane. Similarly, if I'm running a data center or I'm running a university and I'm buying electricity, and then people are leaving their room and the AC is continuing to cool the walls and the floor and everything else in the room, and you come back into the room and the AC is cooling the walls and the floor plus you, but you are only about 1% of the surface area of a 15 by 15 room. So why do we even have ACs that cool only, that can't cool just you, but have to cool everything else that might not need cooling? All of these are part of the problem. The part of the problem is that we are looking at our comfort. We are not looking at the sustainability of the planet. And perhaps we're not asking the hard questions. But scope 3 is a big one, because it's the not in my backyard scope. Something somebody else has done, it doesn't bother me. But when I fly an airline, do I ask, how sustainable is that airline? Probably not. When I give my garbage to the garbage wala in my community, do I know what he does with it and what the life cycle carbon emissions are? Certainly not. When I fill petrol or diesel in my vehicle, do I ask how many kilometers that petrol, a liter of petrol or 10 liters of petrol travel to get to me? Because keep in mind that for 1,000 kilometers of diesel transport, I'm spending 1% of that diesel. I never asked that question, but at least I should be aware. And really, for any manufactured goods, there are 5 areas in which we must look to assess the energy and the associated carbon footprint over life. And it will surprise some of you possibly when I tell you that a study in China suggested that 2% of all of China's industrial emissions came from a single product family. Before I go to that product family, let me give you 3 quotes about sustainability and tell you that the root cause is machines. I told you that already, but now I will tell you that the root cause is machines compounded with overconsumption. Every time I buy an extra t-shirt that I don't actually need, a machine has run somewhere to make that t-shirt. A vehicle has run somewhere to bring that t-shirt to a mall or a shop. A light bulb has glowed somewhere to light up the t-shirt in that mall or shop room so that I can see it. I have spent power to go and buy that t-shirt. So if it's a t-shirt I did not really need, what have I done? Again, Professor Satzikarakis, one of the greatest thinkers in sustainable living, profoundly influenced EU's direction of sustainability, very much worth a read. And a lot of these has been driven by 2 terms that we hear often: gross domestic product, which is the key metric of economies, and shareholder value, which is the key metric of corporations. Because the focus is on these 2 and not on the 17 SDGs, we see this outcome. And that outcome is translated into overconsumption of resources of all the 4 kinds, And all of them keep growing. There's the 2009 report. There's a new one in 2021. And every resource that is extracted is not only causing anthropogenic climate change by itself, but the extraction, processing, and delivery of the resource to the end user is using machines, and those machines are also contributing to climate change. That's what machines do. Everything. Every little thing we do around us does this. And if we are sensitized to each machine that we use, we will ask different questions. And I'll show you one question that we asked with some very surprising results. And that question that we asked was, what is the fastest way to decarbonize a machine, any machine? And the answer is reduce its frictional thermal losses. And how do I do that? Simple answer, use the most optimal lubricant and make sure that the machine is always optimally lubricated. Just optimal lubrication of every machine on the earth can save us 80 million tons of carbon dioxide equivalent of GHG emissions. So if you are running any machine anywhere, ask your AMC provider, ask your institute engineering department, ask the guy who sold you the compressor, how do I keep it optimally lubricated? If a car has an oil change, don't delay it saying it doesn't matter. It matters. It matters to the climate. This surprises you probably. Ceramics, a study in China showed, contributes to 2% of their entire industrial emissions. 2%. So a glazed tile, earthenware, pottery, refractories, bricks, whatever ceramics we use, ceramics are typically fired at about 1,000 degrees, and they are big users of energy. So do I need to use ceramics everywhere that we do? Do I need so much decorative ceramics? Can I do with more functional ceramics? Will those functional ceramics last as long or last adequately as long compared to glazed ceramics or ceramics that have required a higher carbon input? But just look at this one industry. You never think of a ceramic as a carbon footprint problem, just as you never think of lubricants as a carbon footprint solution. But when you start looking at the data and going very deep, you discover new things. Let's now look at just India. I am betting that every single one of us has here studied somewhere in our lifetime, in our education formal system, that India is a net importer of energy, of fossil fuels. I submit that we have been taught wrong all our lives. We are a net importer of carbon atoms because we have been groomed to a diet of fossil fuels all our lives, but non-vegetarians have been taught to become vegetarian, and there are cities in India which are fully vegetarian. Where I go, I'm a omnivore. I eat anything that is mobile or stationary. But when I go to Amarkantak or Haridwar or Rishikesh, I'm perfectly happy to eat vegetarian food. And that's our carbon diet. We, in 2018, and this number has gone up a little since then, we imported 350 million tons, give or take, of carbon atoms. But if I reduce my total energy requirement, I wouldn't have needed so many atoms. If I replaced carbon with non-carbon energy, I wouldn't have needed so many atoms. And also, if I had found those carbon atoms inside the borders of India, I wouldn't have imported so many atoms. Now, the question is, what is this on the ground? It's very nice at this high-level theoretical, but on the ground, does India have some carbon atoms to spare? What I loved is that this time when we talked about, our Prime Minister talked about Panchamrit, and we talked about 5 targets. All these targets ultimately go back to the carbon intensity of the economy. And the carbon intensity of the economy, the generation of CO2 and methane particularly, links to how many carbon atoms we use and how we use them. And now let's go to the brass tacks. Let's start with the supply side solutions. Where are my domestic carbon atoms? We are the second most populous nation. If we are looking for carbon atoms by growing jatropha trees, we are making a big mistake, because we don't have the same arable land to population ratio that a US or a Brazil does, which we try to ape. The US has less than a third of our population with 4 times as much of our land. So we should not being an orange, try to adopt policies and techniques that are used for apples. And here is a summary of how many carbon atoms we have that we're throwing away. We are throwing away every year 460 tons plus of carbon atoms, not including our massive coal reserves, which there is some move for people to tell us not to use. But if I move coal 100 kilometers versus importing natural gas from 5,000 kilometers, are we really looking at our net carbon footprint? So all the carbon we need is available within our borders. It just needs a very, very, very different mindset. I assure you that if we learn to use our carbon, a day will come, not far. And I'm willing to bet that day will come in 10 to 15 years, when India will say, I don't need to import any carbon atoms. And when India says that, even if it does not do that, what do you think will happen to the global price of energy, of petrol? Because India is a very significant player in the demand. And the day we start reducing our import demand, we will actually drive energy equity across the world. It's not easy, but it's possible. And it needs water, it needs energy, catalysts, equipment, labor, it needs a lot of things. But it's just about retraining. Just as today, people who are the poorest of the poor have mobile phones and know how to use them. You know, we have an app called Kisan Sabha. We launched it during the lockdown when farmers were having difficulty because migrants had moved back to the cities or to their villages and needed something to do. We launched this app to help people get their product to the nearest mandi or the nearest society or the nearest food processing unit economically by giving them transparent data on truck availability and truck movement. We expected to enroll 10,000 farmers when we started this in June of 2020. 2 years, 2 months down the line, I have 8 lakh farmers in the system, 800,000 farmers, along with several thousand other people, including middlemen, who now see that an integrated, transparent app actually adds value at all points in the value chain. And I dare say that by doing so, we have also decarbonized significantly. So let me give you a decentralized example. You would have all heard of biodiesel. What you've probably not heard of very often, and we are happy to do these demonstrations across the country if you will host it for us. We are able to make biodiesel at room temperature with unskilled labor, with whatever waste oil you can find in your neighborhood, including used cooking oil, animal fat, fish oil, tree-borne oils. In Karnataka alone, there's 100,000 tons a year of Karanjia oil that's available. In the city of Mumbai alone, there is close to 150,000 tons of used cooking oil that is technically available, whether it's collectible or not. And just testing it in real life by telling restaurant owners and dhaba owners that we'll give them half a liter of fresh oil for every 5 liters of used oil, we could collect more than 4,000 liters in this Char Dham Yatra. That's 4,000 liters times 3, 12 tons less of carbon dioxide emitted to the atmosphere this year because of this one little intervention. And we do this on the tabletop. You can make your own biodiesel in your communities. It's a very inexpensive investment and it pays back 5 lakhs or so for the equipment, pays back in a little over 3 years. It's a subsidy-free investment. And if we can get one of these into 10% of India's villages, India has 600,000 villages, 10% of these gives me a 60,000 barrel a day decentralized refinery with a much, much lower carbon footprint than a 60,000 barrel a day centralized refinery like Digboy in Assam. Similarly, the same collection mechanisms and utilization of our wastes, for example, those in the rubber trade or in the tobacco trade, they never use rubber seed oil or tobacco seed oil. It simply falls to the ground, rots, emits methane or CO2 and is gone. But we can use those oils, we can use the animal fat that is thrown, we can even use the sewage from this, the mega cities of India to fly these planes, and we actually fly them. Almost every month, one plane is flying on some kind of seed oil, on some kind of waste cooking oil or some animal fat, and we make them with pride on our own campus at a modest 30 liters a day. Every time we have 1,000 liters, we go fly a plane. Similarly, inside the Kachra dump in Pune, we ran this unit for 4 years. It was IoT, so I could run it from my laptop. And what it would do is it would take biogas, which is a very well-known technology, using fruit and vegetable and food waste abundantly available in our cities. And that biogas, we would purify through a very simple process, which we call two-column vacuum swing absorption. We would purify it to biomethane, which is basically as good as natural gas. And we can directly feed it to a pipeline. And India has enough, more than enough natural gas or bio PNG potential to not have to import natural gas at all. The government has launched a scheme called Satat to incentivize these projects, and I hope that we will see many more of these in the months to come. Another issue in all our cities, but also in all our tourist spots, is plastic. Today, our little plant in my campus is supported by 17 plastic banks that enable us to collect this through communities of children, hospitals, school, restaurants, cantonments. And in our campus, we are able to convert it either to petrol or to diesel or to chemicals for the petrochemical industry. It's one of our pride and joys on our campus. It's a 5-story high building. It is run all by young BTechs, usually fresh graduates and ITI trained staff, with all the safety precautions of a petroleum operating unit. And we've signed agreements with Delhi municipality and hoping to sign a few more to put viable plants and collection mechanisms across the country. Now that was on the supply side. How do I use domestic carbon? The other question was, how do I reduce my carbon usage? So here is one. If you have pipe gas, and if you have installed in your house pipe gas, but you kept your old stove and somebody came and fiddled with your burner and said, now it is good for use, this is not true. The old burners were designed for LPG, which is a heavier than air gas, and pipe natural gas is lighter than air. The same burner cannot contain the gas loss that you get, and you lose 20 to 25% of the gas. That gas that you're losing is methane, and that methane is 25 times more potent than CO2. Please switch to an energy efficient burner. You will find the energy efficient PNG burners in stores and online. Look for the certification that says it is certified for PNG use. These are sold by EESL across the country and are manufactured by 40 of our licensees. It will give you more than 50% lower net operating cost compared to LPG stoves that you're using today. Not to mention how much we're saving in terms of the carbon footprint. Similarly, if you're going to throw away a car, if your car is about to get past its life and you're about to scrap it, please don't scrap it. Please talk to us. We are trying to set up a national ecosystem where every car that is due for scrapping, we will turn into a permanently living car, an immortal vehicle. We'll take out its engine, we'll put in a battery, we'll put in along with the battery a motor, and that car will run as an e-vehicle with a 40 to 60 kilometer top speed. But at least you're not spending the carbon footprint of scrapping it comprehensively and then having to transport the car maybe 100 or 1,000 miles, then putting it in a furnace, melting the iron, making something else. We do believe that retrofitting and retropurposing of not only vehicles, but even gensets of other things that can be retrofitted and be made to work efficiently with new and improved technologies is a big, big step towards decarbonizing our system. So, I mean, I could go on, just as Tejal said, I can go on for a very long time on this topic. It's what we live and breathe in our institute. But the fact is that sustainability is not just fashionable, it's an imperative. And that imperative is best serviced when you have value chains properly structured, well studied, every participant sees value, and you decentralize so that the people who are participating in decarbonization are also using the reduced carbon alternatives. That actually will raise equity because then you're not paying for somebody else's freight and you're not paying for somebody else's production millions of kilometers away. That needs R&D, but more than R&D, my PhD guide, Professor McDermott, who Dr. Narayan referred to at the beginning, used to say, it is the narrowness of the human mind that we divide knowledge into compartments. It is now the time that we scrap that narrowness. Scientists are no better than those who study sociology, anthropology, public policy, commerce, or anything else at all. We need every piece of knowledge in our value chain and every piece of knowledge available in both modern and traditional thinking to come together and find solutions for energy decarbonization. The rewards are like this. This is our campus. We measure our biodiversity periodically. We had 64 bird species in 2017. We took away all mobile towers from the campus. It has really not affected our communications because we have put Wi-Fi wherever we could. But our honey yields have gone up. We have more than 90 butterfly and moth species, and that is the road I walk every day. Thank you very much for your time.
Thank you very much. And I think we'll jump straight into the questions because we have quite a few of them. I think one set of questions is about technology, specific technologies. So, for example, what are your views on the small modular nuclear reactors? Because that is, SMRs are now quite, they're being considered, they're being discussed, and the global, discussion on nuclear is also shifting. So given the fact that we have, limited space to use fossil fuel resources, what is, and scale in nuclear, what does that, what are your views on that? That's one. Another is, given the amount of energy required for the production of crystalline silicon and the efficiency that you then eventually get out of it, the energy concentration is very less as compared to carbon. So is solar therefore really sustainable? Is the next technology related question. And of course, then there is the question of scale. At what level, where are all the, what are the challenges of scaling up all of these technologies you discussed today, and the challenge of commercializing them, what is being done? So maybe we can take those three first.
Yeah, I think those are good questions to start with. All decentralization requires an understanding of the carbon footprint of centralization versus decentralization that will get you to the sweet spot or the sweet zone for scales. For small modular nuclear reactors, there is clearly a better understanding now that if you can do it in the vicinity of the resource base for the system, or if you can move the reactors, the cost of moving a reactor is actually much less than of building a very large centralized reactor. The risks are also progressively lower. But it's a complex topic. I would say that today, the way nuclear technology works, you have to enrich the ore that is being used and then transport it a pretty significant distance. And then you have to build a very large number of safeguards because your plants are large and critical and grid linked. As we see ability to do off-grid nuclear, we will almost certainly see a change in that paradigm and moving towards the direction suggested. Similarly, the other question on solar cells, that is not, the question is not strictly a comparison of, again, apples and oranges. When you produce a single crystal solar cell, you do actually use high energy, but on a very small volume compared to the volume you would require for the same kilowatts of carbon-based energy. And carbon-based energy is a continuous consumption of that carbon, whereas a solar cell is a one-time production, and then it will be delivering for about 25 years. So on a life cycle basis, solar is shown to be better, even at low efficiencies, which is why even amorphous solar, which is only 8% efficiency, does have some value in use. But clearly, the need is to keep making solar cells more efficient. Yesterday, in fact, today I'm still in Calcutta, but yesterday I was at the Central Glass and Ceramic Research Institute, and an anti-reflective coating made there improves the efficiency of solar cells by 1.5%. That would seem small, but on a 15% efficiency, 1.5% is actually 10%. So it would effectively decarbonize by a further 10% of what it was doing. So I would say solar energy is sustainable. It's not carbon neutral, but it is sustainable, or it's moving in the right direction. The challenges of scaling up any of these technologies is primarily enough people to see and believe in it. It's like scaling up of mobile phones. A few people try it, then more people try it. You prime the pump by giving maybe some early incentives to have enough people do it, and then eventually everybody's doing it. So like the biodiesel that we talked about, when we first talked to people, there was disbelief that you can make biodiesel at room temperature, but you can. Thermodynamics tells you can. Engineering tells you can. When we first demonstrated it, we actually had people come in and take it apart to, see whether we had something hidden behind some magic puria. When we showed it wasn't, then we got the first plant. And today we have 40, 50, 60 inquiries. We have people coming to us saying, please give us the technology and we'll put 100 plants in the next 2 years in our district. So we know it can be done, right? And the last question on this, which was on the, the pyrolysis oil from plastic waste. It is absolutely a viable option, but you don't use just the pyrolysis oil. You need to have technologies to clean up the oil and make it into a useful fuel. Otherwise, the pyrolysis oil as is made today from plastic waste or rubber tires will corrode your boiler or damage your engine. And anything that's corroded or damaged is extremely carbon impactful, because you'll either have to simply throw it away and get a new one involving machines and fabrication, or you'll spend both money and carbon energy fixing it. So we need upgrading of pyrolysis oil research and better than has been done. Thanks. Back to you, Tejan.
Yes, so now we have a few questions on policy. One is, of course, whether there should be some judicial intervention to basically nudge society into reducing carbon footprints, because whether political decisions can be taken given vested interests, etc., remains a question. So therefore, should we have some judicial intervention? And there's, of course, there are question marks in terms of how this happens in a democracy, but I'll leave that to you to field, Anjan. But we have another question on, the gas exploration issue that we were talking about being sustainable or self-sufficient in gas when the new exploration and licensing policy first was introduced. There was a lot of hype around how much gas we are going to have, but of course, all of that has come up proper. We don't really have that much gas. So was it simply something that was to increase the stocks of certain exploration companies, or do we really don't have gas, or do we have it, but we don't know, we're not exploring enough? That's the second question. And of course, the third one is about lifetime of products. Do we have how is sustainability connected to consumption and therefore also lifetime of products? Should there be any regulation on this? Because if you just have smaller lifetimes of products to increase sales and increase profits, then that affects sustainability as well. So over to you again.
Again, I think all of these are very relevant questions. Some answers are self-obvious. For example, products that are deliberately short cycle and are then replaced by new products, and the warranties of the old products expire, so you have to buy new products. I think that's a pretty unfair trade practice from a climate change point of view. I won't name the offenders, but I think all of you know companies, particularly those that sell electronic products, tend to generate new generations and then remove support for the old generations. You're forced to not only buy, but you're forced to scrap. And I think more extended producer responsibility is required here, with much greater public transparency on product life cycles. The question on oil and gas fields and exploration is a more difficult question. The geochemistry tells you only probabilities. It doesn't tell you about the ease of extraction of oil or gas from a field. For example, in India, we also have a lot of coal bed methane, we have shale, but they are sitting in eco-sensitive zones. And I will actually say that the government should be complimented in not having gone there yet when other options have not been exhausted for economic self-sufficiency. Because once you start doing what the US did on fracking, the impact not only on global climate change, but on local ecosystems can be devastating. We certainly should think in terms of carbon capture, as Pratap Makwana has mentioned on the talk. But carbon capture also has its own carbon footprint because it needs machines. So please don't believe anything on carbon capture till you do the homework and measure the carbon footprint of every proposed carbon capture mechanism. And then the judicial question, I will probably want to sidestep that a little bit, It's not about vested interests. If people see, if people understand that climate change is linked to public health, if people understand that climate change is linked to well-being, and the public says to the politician that we want a better climate, a better earth, less floods, better events, and they're educated to show that unbridled development or skewed development is a cause, I think that will bring larger solutions than judicial intervention, because judicial interventions have their own timescales. But I think that it is up to us to educate people. We can't say the education system is flawed. I would talk to every person I meet, I still do, whether it's an autowala or whether it's a person who comes to do housekeeping in my institute, or whether it is somebody I casually meet in Uber, and I'd be surprised at how aware these people are and how little nudges have multiplier effects. I am also a big believer in social media. I like to make sure that critical things get put on YouTube or Facebook, where somebody will see it. There is so much negative or misinformation. Let's put some database information out there, because if you're not part of that solution, we are in some way part of that problem. Thanks, Tejal. Back to you.
I think we have covered. There's one more question, of course, about the fact that the inefficiency of the way in which we use energy. So basically, you have room, you have conditioning of an entire space just to cool an individual human being, or the huge amounts of fossil fuel-based electricity that is then used to drive a car, just move one human being from one place to another. So simply, so this is a question about systems of energy use, and it's not just a matter of where it is coming from, but how it gets utilized for what purpose. So, you know, end use versus so I will give this to you to answer. You did discuss it quite a bit.
That's probably closer to your field than mine, Tejal, but really what it talks about is mass transportation systems versus individual transport. And I think that more and more, as you create tax structures and economic incentives for mass transport, as has been done in Europe and other parts of the world, we will see more of that. But in the US, you notice people don't carpool very much. You have a lot of individual drivers. If you go to Jakarta, people are forced to carpool. In the evenings, if you don't have 3 people in a car, you can't use the fast lanes. You have to go in the slow lane. So people are learning through incentives to do so. And all of these are really about what we've been used to. And the paradigm shift will come from a combination of technology, awareness, individual motivation, and policy nudges. Thanks.
So I think we have gone through all the questions. So there is, of course, there's one which talks about can we differentiate between natural climate change versus anthropogenic induced change, and another one that also is, is referring to what we can do to perhaps get developed countries. What do we have as leverage for to get developed countries to do more? So that's a policy question. The second one, the first one is about the way in which we differentiate between anthropogenic global warming and natural climate variability.
Why don't you take both? You're the expert there, Tejal.
I think there is it's very clear now. The science on this, on the difference between the two is very clear. In fact, the 6th assessment report, the working group 1 report, very clearly also provides the range of uncertainty around natural variability, the anthropogenic contribution, so human influence versus natural influence is very clearly differentiated. There are ways in which this is measured. There are statistical techniques that are used to look at paleo data to differentiate between what we have caused versus what natural variability is. On shorter time scales, this is a little more challenging to do, but on extremely long time scales now, the science is very well advanced and quite significantly published as well. So we have enough information to differentiate between the two. There is, in fact, unequivocal evidence and universal consensus among scientists that what we are seeing is, in fact, anthropogenic global warming. We have got It is not. And we, of course, is a differentiated we. Some some people on the planet more than others. So don't hold the poorest sections of the global community responsible for the mess we are in. But there are, of course, it's the human species that is really the problem. The other question is about leveraging, what leverage do we have? It's simply that we are more in number. It's 80% of the global south. We are quite a large section of the global population. And if at all there was a point in time, for example, where this group, this bloc really did negotiate together against countries of the global north, on various issues. It is possible on climate change also, the G77 bloc has common positions, but the global countries of the global north are much more united in their positions and are very blatantly and very clearly, have positions that dilute questions of equity and issues of climate justice, which are quite central to all that Anjan was actually saying. I mean, it was central to poverty alleviation and development, reducing inequalities is central to an agenda of sustainable development. And this, if we are to realize it, then we have to also address the question of global inequality. And this can only be done if the countries of the global south, South-South cooperation is, I think, an extremely important element of how we go ahead on this. And it's not about what leverage we have. It's simply the fact that we are too many people and too many economies to simply dismiss. And so if we actually have, you can't dismiss China and India, for example, even single countries, we can't be dismissed. So imagine other countries with whom we have much more in common across the global south, negotiating together and on common positions on this. It is much more difficult than for the global north to dismiss. That's why we have a very progressive UNFCCC, right? The convention document is actually extremely progressive for the time that it was constructed. And a lot of the language comes from negotiators of developing countries. So I'll stop there. And I think we have taken most, all of the questions. So I'll hand over the proceedings back to, thank you very much, Anjan. I think that was a fascinating discussion. I'll hand over back to the organizers for the wrap.
Thank you, Tejal. And this has been a very interesting discussion. And I want to start by thanking both Anjan and Tejal for the very valuable inputs that they provided over the last, through the evening. We've had, I think, a very important discussion today. One of the things that happened when we had the IIT industry conclave a couple of years back, just before the pandemic, was whichever panel talked about how do we look at India's growth into the 5 trillion economy and so on, every single panel, the issue of energy came up, and the issue of sustainability followed thereafter, saying that we have to look at sustainable mechanisms of growth. And so I believe that today's discussion is a very valuable add-on to all of that conversation. So I just want to make a few summary remarks. I'll start by saying that the MDGs, which guided the development agenda until 2015, it did end up doing a lot by way of poverty alleviation and so on, but it did leave a lot more that many questions, as well as a lot more that needs to be achieved. Especially in the area of climate change and environmental degradation, the realization that those areas are going to affect the poor even more than they would everybody else. And therefore, the impact of all of that on poverty alleviation and the fact that many that have struggled out of poverty fall back into poverty. So therefore, the importance of climate is cannot be undermined in any manner. And this has been recognized in the next round, which is the SDGs that govern the way we look at things today and under the UN umbrella. And the 17, amongst the 17 SDGs, 2 which are the clean and affordable energy for all and climate action. These 2 were the topics of and the focus of today's discussion. I like something that Anjan said, which was that if we look at sustainability and a sustainable world, we should think not about just the human species, but every other species. Thank you, Anjan, for that statement, because I think it's a very significant and important one. We all know that what is called human development has been at the cost of the loss of many, many species, different kinds of species, animal, birds, everything, and also the degradation of soil and all of our other natural resources. So obviously that is not a good answer. So when we think about human development, we really have to redefine what it is. And again, Anjan said that while there is no single right answer, each country and each region needs to find solutions for itself, things that matter to it, the things that would make a difference and therefore help them get the right answers for themselves. India is unique, and we need solutions and models that are specific to us. While most of the models and the technology that we've used so far has come from the West, a lot of people are now questioning what is appropriate to us. We also need evidence and data-based decision-making to make sure that we get it all right. But what we realize is that while something like pollution is a local issue, climate is global, and therefore a lot more global dialogue and data transparency is required. Data sharing and data transparency are very much required to be able to enable everybody in the world to make the right decisions for themselves. Tejal, something that you said again, which was, I thought, very significant, is that the science of climate change and sustainability has to be looked at in the context of geopolitics. It cannot be segregated, it cannot be taken out and looked at just the science. It's very much impacted by the way geopolitics plays out. We then looked at the root cause of environmental problems, and Anjan gave us a lot of background, helped us with understanding the terminology that is thrown at us day in and day out when we look at all of that conversation around green and so on. But the root cause, he said, was overconsumption. That overconsumption, while it also leads to the overconsumption of all available natural resources. And also, to be able to make all of that work, we end up using more and more machines, and thus machines become very important and become actually the reason why we end up with the environmental degradation that we are seeing. He then went on to talk about many actions that we can all take, all of us can take, such as lubricating every machine, whether that's in the domestic personal kind of situation or in the corporate factory kind of environment. Again, we should be asking ourselves questions such as, do we really need these decorative ceramics, for example? And again, if we are going to be using piped natural gas, we should be using the right kind of burners and not using, let's say, the old LPG burner adapted. He then helped us understand the idea of Panchamrit and India's commitment at the Glasgow summit. And from there arose two key questions. How do we reduce the wastage of carbon, and how do we reduce needs, which is the consumption of carbon? And he showed us with various statistics and figures that India does have enough carbon to meet our own needs. And then finally, we looked at supply side and demand side innovations by CSIR IIP. And some examples were the room temperature diesel, plant. And Anjan, we'd be very happy to host it at the IITACB when our new building is inaugurated a few months from now. So that is probably something you would be happy to do. He also talked about biogas and how it can be used even for aviation and auto fuel, and told us a beautiful story about how they collect enough and then run and then fly a plane. Love that story. Also plastics and how they can be converted to petrochemicals, diesel or petrol. And we had a little discussion around that during the question and answer session as well. On the demand side, a retrofit kit for conversion of the old IC engine in a car to an e-vehicle. And the similar concept can be applied for anything like a genset, and thus we have long-lasting machines, which will kind of run forever. And that again does call for a rethink on our part, because over time we've been kind of brainwashed, if I may say, into believing that you need to change your car every few years, you need to change various kinds of implements every few years for whatever reason. So in conclusion, he was telling us that decarbonization is an essential component of sustainability. Value chain participants who are responsible for helping this whole decarbonization process set in should be incentivized, both to invest and grow the value chain. But all of that necessarily means decentralization. And that brings us to the subject of and the topic of today's discussion. And then, the concluding pictures were beautiful. So is your profile picture, Anjan. On the IIP campus, he talked about the 90+ butterfly moth species, the increase in honey, the bird species. And yeah, I mean, that is the world that all of us kind of hunger for and really look forward to bringing back and seeing someday. We've seen how that can be done, and how the fact that a lot of that action lies in our hands and not elsewhere. So thank you again. Many, many thanks to our audience for being here with us today, for all your questions and the discussion. Tejal, thank you so much for both your very insightful comments and moderating the discussion today. And of course, Anjan, thanks ever so much for the work that you put in, as well as the webinar and inputs today. This webinar recording will go up onto the IITACB YouTube channel come Monday, and all of our other webinars are there as well. Please do participate in our webinars. We have some wonderful speakers and great subjects. And do write in and tell us if there are other topics that you would like us to cover. We'd be more than happy to get wonderful speakers like today's. So thank you very much, and Jai Hind.
Thank you. Bye-bye.